Ladies and gentlemen, now we will be having the presentation on Smart Meter Operations Centers by Mr. Udit Poddar. He is the CEO, Grid Pragyam Data Technologies Private. Udit is a data scientist by training and is the CEO of the company. He leads the sales function in the team. If we talk about his education, he is Bachelor of Science Economics from St. Xavier's College, Kolkata. 4 years of experience as a data scientist at MU Sigma, Atlin, Quizzes. Udit was one of the first data scientists at both Atlin and Quizzes and worked extensively in establishing the data-driven growth and monitoring setup at both the startups. Udit will be talking about a lot of very important things like operations monitoring for smart metering programs, the need for the near real-time monitoring of AMI, current data management landscape and challenges in 360-degree monitoring, introduction to no-code, low-code in operations monitoring, agility and interoperability as key advantages for future readiness, applications like WFM, SMOC, meter data analytics, beyond meter to cache, and AI readings. Let's welcome Mr. Udit Poddar on stage. He is the CEO, Grid Pragyam Data Technologies Private. A warm welcome.
Thank you so much, ma'am. Hello, everyone, and welcome to all of you. So my name is Udit, and I am the CEO of a company called Grid, commonly known as WorkOnGrid in the industry. So the agenda for my today's presentation is going to be to discuss the importance of preemptive operations monitoring for smart metering programs, discussing smart meter rollout programs and also the SMOC concept. We will be discussing these in the light of no-code, low-code platforms, right? So we are one of the leading providers of no-code, low-code platform in the industry that has various different use cases. So we'll be covering no-code, low-code from a perspective of workforce management as well as SMOC. We'll discuss the interoperability and agility that a platform-driven approach provides to solution development, to software development. We'll also be discussing the benefits of using low-code, no-code platform for use cases such as workforce management and smart meter operations center, and then discuss about AI readiness and integrations, right? I mean, in all the conversations that we've heard so far, we've heard interoperability multiple times, integrations, data structures, and all of that, right? So I'll be covering these aspects in my presentation today. So starting with the first part, what is the importance of real-time operations monitoring, right? When we talk about smart metering programs, they are typically huge right now. Like, you know, anywhere starting from 1 million meters to 5 million meters is what is being implemented in the country. Real-time operations monitoring from a perspective of meter rollout programs as well as from a perspective of asset monitoring can have huge advantages for the AMI SPs and the utilities, right? It helps in preemptive troubleshooting of issues that may arise typically during a meter rollout program or monitoring of these smart meters. It can help us in faster detection and resolution of issues, which has a direct impact on the customer service and the experience that we give to the end customers, right? And the most important aspect of real-time operations monitoring is its impact on the bottom line of any project that is being executed today. Via efficient utilization of resources, which is human resources that are deployed for such programs as well as the assets that are implemented or that are being installed in these programs, right? So real-time operations monitoring can have a direct payback, have a direct impact on the payback period of smart metering programs today. It reduces the operations and maintenance cost like, you know, drastically by giving preemptive solutions to the utilities, and it can have a double-digit impact on the operational margins of programs that are of meter rollout programs that are going on. Coming to the challenges, in monitoring smart meter programs today or smart meters today. So we have huge variety and volumes of data, right? We've heard from SAP, we've heard from various different speakers talking about different platforms. When we talk about smart metering programs, the data that is coming or the data that is available with AMISPs today are huge and varied, right? For example, inventory and assets typically sit in ERP systems. A project execution plan sits in products like MSP, Primavera and other project planning tools. The actual project implementation happens on bespoke workforce management tools. Again, workforce management tools here, like, you know, typically companies are using it for CI/MI activities, but all the data related to actual implementation of metering programs are in workforce management tools. The HES and MDM hosts the meter data, right? The operations and maintenance of asset, which has not even started in large scale today, but also happens on bespoke applications that are being provided by various organizations, various companies. We've not even started working on quality audits of this huge infrastructure that is being developed today, right? When we talk about workforce management, tomorrow quality audits, meter audits, transformer audits will become a big requirement and need for the sector. And reporting in BI is disintegrated into each of these various applications. To get information like how many consumer indexing exercise have been done, how many meters have been installed, or how many meters are communicating, companies typically need to look into two different tools to get even these three numbers. So this is the key challenge in actually preemptive monitoring of smart metering programs today, right? What does this cause? It causes lack of consolidation and centralized monitoring of these programs, which in turn causes efficiency losses. And given the kind of pressure that are there on operational margins or on the margins of such programs today, efficiency losses can actually be drastically reduced if we talk about, if we take a platform-driven approach to operations monitoring. Now there are two perspectives to it, right? From a utility perspective, we heard different utilities have different software stacks that they have taken. Workforce management, MDM, HES, all sometimes coming from different companies. How do we actually create a single monitoring system, right? The classic problem of interoperability. How do we create a single monitoring system to monitor various projects and various products and the data that we are getting? And from an AMISP perspective, AMISPs are again running multiple projects. How do you create a plan or how do you create a view to monitor all projects together? So a platform-driven approach with principles of no-code, low-code can actually help companies solve this problem. So before getting into how low-code, no-code platforms can be used, let's look at what low-code, no-code platforms are. The concept has been there since, the concept of low-code, no-code has been in the market since quite some time now, but it started gaining traction in 2018, right? And different sectors like BFSI, healthcare have big penetration, have big usage of no-code, low-code applications today. A low-code, no-code platform is a development environment. I'll repeat myself, it is a development environment that enables non-technical users to deliver software applications using a graphical user interface. Which means, if we talk about workforce management as an example, if CI/MI activities are going on in a typical workforce management tool, and the utility needs to also launch a meter audit or a transformer audit application, if they are using a low-code, no-code tool, they can actually extend it to provide an audit application to the users without creating a change request, right? So that is what the power of a no-code, low-code platform, that is what a no-code, low-code platform is, and that's what it brings to the table to the industry. So coming to what is the construct of a no-code, low-code platform? So it typically has a drag and drop interface to build and deploy applications. It has reusable components which are built for specific customer needs can be reused by different customers as well, which means build once, use forever and use in variety. There are out-of-box integration and data processing layers available. We know integration layers and integration is such a big problem in the industry today. Every company has its own data model, every product has its own data model. How do you integrate with them? So integration It comes with an integration layer that facilitates integration much faster. It also has an active reporting and a dashboarding framework so that we can bring data together from multiple systems and deliver KPIs to the end customer the way it is required. And also platforms, since there is a platform-driven approach, it comes with multiple deployment models and are typically cloud agnostic, right? So they can be deployed on any kind of cloud infrastructure or on-premise servers and so on and so forth. So there are huge benefits of using low-code, no-code tools to actually deliver software for smart metering programs or like, in the industry. They are very, very fast, saves up to 65% time that goes into software development and customizations. Secure, because there is a platform-driven approach, most platforms typically opt for security certificates like ISO, SOC, etc., which are readily available then. They are very, very powerful. It enables functional users to deliver technology solutions, making it extremely powerful. It's cost efficient. We're not spending a lot of time on custom coding and development, which means it can be delivered at a much reasonable cost. They're scalable, typically built for scale. Start with 200,000 meters or 2 lakh meters, scale it up to 25 lakh meters. Scalability is available because it's again a platform-driven approach. And they're enterprise ready with multiple models, audit logs, and all the requirements that typically enterprises need for actually deploying any software solution. And the two key main benefits are that it provides agility and extendability, which means you take a no-code, low-code platform, build some use cases and expand it to more use cases without actually further procurement, right? And also brings interoperability, which I'm going to talk about a bit later when we talk about SMOC, how no-code, low-code platform can actually enable interoperability, which is such a big problem in the industry today. But yeah, they also enable interoperability, right? When we work with customers, when we use no-code, low-code platforms to deliver solutions in the industry, typically they integrate with the ERP systems, they integrate with MDM, HES systems, project management tools to deliver an entire operations monitoring system for the smart meter program, right? Where workforce management, audits, health and safety, and all such other processes are typically built on such platforms. Coming to the applications, I mean, since it is a concept and it has been around there, talking about some applications and applicability of low-code, no-code in the industry, workforce management is a big one. Workforce management, again, we're not just talking about CI, MI and inventories here, we're talking about the tracking and requirement of the entire field force that can be delivered through such solutions. And then smart metering operations center where multiple products can be integrated to create holistic dashboards and reports for the end user, for the utilities to monitor their programs and their assets, right? So these are typically two example use cases that we can think of low-code, no-code. Having said that, given the construct of such platforms, they can be extended to asset management, task management systems, and multiple other use cases that are there or that will arise in future, right, for utilities and AMISPs. Talking about application of low-code, no-code on workforce management, as I mentioned earlier, the biggest advantage is that it is fast and allows quick customizations. So imagine CI applications, MI applications can start within a few days of starting the project without actually having to sit and create custom coding requirements. It also allows flexible work allocation methods and flexibility in data structure. So after say CI, which is again a big problem today still in the industry, when it starts, utilities realize they need to capture more information about the customers. The fields, the data lists can be added very quickly with a drag and drop interface, and it provides more flexible work allocation methods and flexibility to solutions, right? With the integrated dashboarding and reporting systems, they can also provide real-time hierarchy mapping for smart metering infrastructure that is being built. Some examples are shown here. The product can also be extended to capture health and safety parameters from the field, right? So if there are any health and safety audits, take fives that needs to be done by the field users, they can be extended to that. And they all, and typically because of the platform driven approach, they are configurable, right? So any kind of configuration can be created within no time. So the delivery of the workforce management tools or field applications are extremely fast and robust when we take a platform driven approach rather than a custom bespoke development of workforce management tools, right? So modern day, so when the concept started, most of the products that were there in the market were horizontal products, which were which were being deployed in different industries. But today, low code, no code is an approach to programming. It is an approach to software development. And there are companies, there are products that are in the industry, for the industry, with low code, no code frameworks as they construct to build and deliver software solutions and applications, right? Coming to another example of using, again, low code, no code products for use cases like SMOC, Smart Metering Operations Center. So let's first understand what a Smart Metering Operations Center look like, right? Or what it is. So it has the ability to connect to multiple systems, whether it is multiple WFMs, multiple HES, MDMs, billing systems, to actually collate data together and then provide views to the user, provide KPIs to the user. So a SMOC typically would have 4 key components. An integration layer, where it can integrate to multiple systems. Again, I'm talking about out-of-box integrations, not custom development here. A data analysis and a metrics lake. It allows users to build a metric lake for their KPIs, a historical metric lake as well. It can do event processing, alerting on alarms that typically comes from multiple systems, and a visualization engine to actually view everything together, right? When we take a platform-driven approach, platforms typically have these 4 key components to deliver Smart Metering Operations Center, right? So typically, when we talk about SMOC, so when we use low-code, no-code platforms like ours for implementation of Smart Metering Operations Center, we typically have flexible and versatile integration layers pre-built, which means the platform can be integrated via SFTP, via SharePoint or file-based systems. It can be integrated via APIs and webhooks. They're all readily available. It can be integrated via data streaming systems like ActiveMQ, Kafka, which are being widely used by various platforms today. There are direct database connections as well, where it can integrate with databases such as MySQL, Oracle, and other relational databases, and can take in data from any system into a single platform, right? The most important aspect to actually allow interoperability between platform is that the platform should support flexible and varied data structures, right? All platforms have their own data structures, the way they are sending data. If a platform that is used to build a SMOC can allow flexible data models, then it can actually accommodate via the integrations any data structure or any data that is coming from different platforms. It should have a data querying capability to create your metrics lake. Imagine there is a database that hosts all meter data, all billing information, etc. But also the SMOC can have a database for your metrics separately, making it readily available in an active reporting and dashboarding framework for users to actually build any kind of monitoring solutions, right? When we talk about currently used solutions today, we can see reporting, dashboarding, and creation of KPIs typically takes time. They are mostly reactive. When users send requests to create a report, they create a report, right? But with a framework, with a platform-driven approach, we can actually move to active reporting systems where metrics are automatically calculated in real time and are presented to the users in form of a metric database. So the idea behind my presentation here today is to onset a platform-driven approach to software delivery in the smart metering space rather than a service-driven mindset, right? It brings huge advantages to extend the platform to multiple use cases, create connectors, create analytics workbench, create integration layers with the platform's capability, and deliver operations center or operations monitoring solutions in smart metering programs. So it is extremely important. As I mentioned today, there are multiple no-code, low-code platforms available in the market. But choosing the right technologies for complete overview for utility scale is very, very important, and it's becoming extremely complex today. So a platform approach, a platform-driven approach to smart metering, operations center, operations monitoring, workforce management systems enabled by low-code, no-code principles can be key to scalability and can be key to extend the use cases of the platform to multiple things that might come in future, right? Coming to some more solutions that can be provided by low-code, no-code tools. So they can be also used for non-AMI meters, non-smart meters. They can be used for creation of meter reading applications, other field force management applications, preventive maintenance of assets, creating schedules for preventive maintenance of assets, and then actually doing the completing the preventive maintenance jobs. They can also be used to create complete enterprise asset management solutions in AMI. While in smart metering, data is being recorded for smart meters, it is being recorded for DCUs. There is huge amounts of data available for antennas, seals, circuit breakers that also need a database, right, to live. So low-code, no-code tools can also deliver enterprise asset management solutions. They can be extended to transmission and distribution networks. Like again, they can be used for maintaining the transmission and distribution networks and then tracking field management, field applications that typically occurs in transmission and distribution networks, and can also be used to create automated task and ticket management systems. With huge amounts of data that is coming from smart meters, it will become mission critical to actually create a proper task management solution for backend operators, right? So how do you create that from the validation data that's coming, from the alarms that is coming in? Again, low-code, no-code tools can be used to create such task management solutions and integrate with other tools like Jira, etc. Coming to AI readiness for future applications, again, taking a platform-driven approach to create an operations center, to create a metric lake can make companies ready for the AI boom. It helps in data consolidation and creation of KPIs that can be further used for model training and development, right, in future to deliver insights from the data. They typically come with integration layers. They can be integrated with off-the-shelf available AI models. We know of so many AI models today that are readily available. And then the output of these models can also be actually delivered in such no-code, low-code platforms, right? When there are predictive analytics happening, when there are predictive capabilities coming in, the output of these models can also be delivered through the UI of the low-code, no-code platforms. It also makes companies AI ready and make sure that they have the necessary data in the available data format consolidated to actually build predictive models and use AI for proper applications. In conclusion, central operations monitoring systems will again become increasingly critical given the kind of margins, given the kind of pressures that are there on AMI SPs today. There is a need to actually move from a service-driven approach to platform-driven approach for faster delivery of software solutions at better prices, at efficient costs. Platforms built on the principles of no-code, low-code actually provide extendability for use cases so that there are no more softwares actually coming to the already huge stack of softwares that exist with AMI SPs and utilities. Low-code, no-code provides agility, interoperability, extendability to software solutions that are being, to softwares that are being deployed today for various use cases. And it also helps companies build a resilient data infrastructure to make them ready for AI and more predictive analytics and predictive capabilities that are coming in, right? So yeah, thank you so much for patiently listening to me, but moving to questions.